All right, it's time to talk about local linearity, and the best way to describe it is to show an example. This looks like a straight line, doesn't it? In fact, if you were to guess, wouldn't you think that this is a straight line with a y-intercept at 0 and a slope of 1, so it would just be the line y equals x. But it's not the line y equals x, it just looks like it's the line y equals x. So how would we figure out what this graph really is? Well, there's a couple different ways we can go about it. I'm in Desmos right now. I'm going to go up here to zoom out because this happens to be a very zoomed in graph. If I zoom out, still looking at it, it still looks y equals x-ish to me. I still look like I have a slope of 1. I still have a y-intercept of 0. Let's zoom out again. Still looks linear to me. I must have been really zoomed in. Let's zoom out again. Still looks linear, still looks like the graph y equals x. Let's zoom in again. Excuse me, zoom out again. I continue to zoom out here. Oh, wow. Now it's not linear anymore, is it? I think it would be helpful at this point to show axis numbers so we know how big we're looking here. So finally, when I get out to here where each of these sections is 1/2, it looks nonlinear. Let me zoom in again, and you can see just how zoomed in I was to begin, where each of these major grid lines was at 0.01. And then if I zoom out, you can see how my scale is decreasing or increasing. I'm not sure. The scale is zooming out. So now this is where I was just a minute ago. This finally looks curved, but I still don't know what function it is. I kind of have an idea at this point. I'm hoping you have an idea, but let's see what happens. Now we can see. This is, in fact, just the sine function. But let me zoom in again and show you that if we zoomed in really far, and actually this just looks linear. That is the concept of local linearization, where you take a curved function, you zoom in many, many times, and a section of that function looks linear. Local linearization.